All right, so on 9.1, number 6, here's the way it's set up. It says, suppose a 50 kilogram cart, no, it doesn't say 50 kilogram, it says 0.50 kilogram cart is set up on a horizontal frictionless track between two springs, each with a spring constant of 4 newtons per meter. A says we pull the cart back 0.30 meters and release it from rest, and we're trying to find the period. All right, so again, we've got a springy oscillating thing. So the equation for period is 2 pi times the square root of m over k. So I know my mass and I know my k, but if I plug those numbers in, it doesn't give me the right answer. You got an idea why?
Wait, this is one with the two strings acting out. You don't have to add their spring consonants, so it's 0.8, not 0.4?
8, not 4, but yes, right idea. Yeah, so look, you guys, there are two springs, right? So instead of just having one spring that I'm pulling some distance, I've got two springs that I'm pulling some distance. Isn't that going to require twice as much force?
Okay. I don't understand if you're pulling it back, so isn't one getting less stretch and one's getting more stretch?
Yes. So here's the deal. So the system actually looks like this, where you've got, if you can't see it, there are springs. Somebody told me last summer that I did this, and they couldn't see that there are springs here. There's springs here and here. Okay? So what's happening is when I push it to one end, what's happening is let me stand behind it instead of in front of it. So what happens is when I push it to one end, what I'm doing is I'm compressing this spring by a distance x, and I'm stretching this spring by that same distance x. Does that make sense, you guys? So even though one of them is being stretched and one of them is being squished, it's still the same idea. I'm still displacing two different springs. Just like over here, I'm displacing two separate springs.
So it needs more force?
So it needs more force. So the idea is, because we're stretching two springs, you need twice as much force for every newton. So in English, you got to double your spring constant. Does that make sense, you guys? Lily, does that make sense to you?
Yeah.
Cool. Arno, how about you?
Yeah.
You good? Wyatt? Everybody good? Alrighty, so that is the deal with number 6. So to do part A, the period is 2 pi times the square root of 0.5 kilograms over 8 newtons per meter. And then to do B, then it says, what if there's only one spring? So now you just use the 4 newtons per meter. Yeah, AJ.
Okay, to clarify, there are two different equations, but they're essentially the same, but different variables.
Two different equations, yeah. There's the spring one, which is the only one we've looked at today, just because of the questions you guys have asked about.
Yeah.
And then there's the pendulum one, which we haven't used today, although it was on the homework. And that's this guy, 2 pi times the square root of L over G.
It's
Where
just 9.
G is 9.8.
Oh, because I was multiplied by the mass. The mass.
So that's the force of gravity, not the acceleration of gravity.
And that's positive.
So I like halfway through the year I switched. So here's the deal, you guys. So in general, G is always understood to be positive 9.8. Okay? At the beginning of the year when we were using it, I always used AG because we wanted to keep track of the direction, which is negative.
But we couldn't because we have an imaginary number.
Exactly. So that's why I used G instead of AG. Same thing with GPE. If you look at the GPE equation, I used G instead of AG. And I think I did not do a great job explaining the difference between those. So, cool? All right. Any other questions on 6? All right. And then somebody asked about 7 and 8. So incidentally, I just realized, did you guys realize that there's, you can't tell that that's 8 because it got hole punched. So there's a few separate problems there. So for 7,